Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at circle theorems. So I'm going to prove two circle theorems here to show you how a proof can be constructed. So here we have the proposition: the tangent to a circle is perpendicular to the radius at the point of contact. So what I want to do here is prove that this line here, which is the radius, is perpendicular to the tangent, this being the point of contact. So sometimes when you're doing proofs in mathematics, you just have to pull something out of the air, and that's basically what we're going to do here. So I'm going to let t be the tangent, so t refers to this whole line, and P is a point on the tangent. So I'll just put P as this point here. It's an arbitrary point. It can be anywhere on the tangent. So let's look at what happens if I draw a line from the center of the circle to this point P. Now, is this line segment here longer or shorter than the radius? Well, it's obviously longer because the radius of the circle is equal wherever. So this line here and the radius here, they must be equal because they're both radii of the same circle. Now clearly the blue line is longer than the green line. So how does that prove that this occurs at right angles? So what we've really just shown, if P and A are different points, they're not the same point, then the distance from O to P will always be greater than the distance from O to A. That's what we just explained. So that means that OA is the shortest distance. Whatever the length of this line segment is, it is the shortest distance between O, the origin or center of the circle, and T, the tangent. And that means that OA is perpendicular to T, that this radius is perpendicular to this tangent here. Now this proves our proposition because we know from geometry the shortest distance between a point and a line is always a perpendicular line segment between the point and the line. Because this is the shortest distance, these two must be perpendicular to each other. All right, let's now look at proving one more theorem involving circles. So we will now prove that tangents from an external point are equal in length. So P is that external point. These two lines are tangents. Now A and B are the points where the respective tangents contact the circle. What we're essentially proving here is that PA is equal to PB. So we're actually going to prove that using congruent triangles. So first we're going to have to draw some triangles. So with circle theorems, we often involve the center of the circle, which we call O for origin. So I'll draw a line from O to B, from O to A, and I'll split this up into two triangles. So I'm going to show that this triangle and this triangle are congruent. So in order to show that two triangles are congruent, you need to show three things involving combinations of sides and angles. So the first piece of evidence I'm going to use that they are congruent is that these two sides are equal. So obviously OA and OB are equal. They are radii of the same circle. The next piece of evidence I'll use, this line here is common to both triangles, so it's equal in both triangles. So now I need just one more piece of evidence. Well, I can't use that these two sides are equal because that's what I'm trying to prove. I can't assume something is true in order to prove that it's true. But what we can do is we can use anything we know from other theorems in geometry or other circle theorems. Now on the previous slide, we just proved that when a radius contacts a tangent, they do so at 90 degrees. So this angle here and this angle here are both 90 degrees. So I've just listed the reason for this as circle theorem. I mean the circle theorem that we proved on the previous slide. So it's important when you're doing proofs that you give reasons for non-obvious facts. So we have enough. We have our 3 pieces of evidence. It is sufficient to show the triangles are congruent. So our congruent statement, we say therefore triangle AOP is congruent, so it's like an equal sign with an extra dash. It is congruent to BOP because of the RHS rule. So we showed that the hypotenuses of the triangles were equal. In fact, it was common. We showed they both have a right angle and another pair of sides is equal. So if 2 triangles are congruent, it means that pairs of corresponding sides are equal in length and pairs of corresponding angles are equal in magnitude. So because this triangle and this triangle are congruent, that means that the other pair of sides we haven't yet considered, AP and BP, must be equal. The reason we give for that is that they are corresponding sides of congruent triangles. So if 2 triangles are congruent, their shortest sides are equal, their longest sides are equal, and also their middle length sides are equal. That's what we mean by corresponding or matching. Here it is the 2 middle length sides. So we're done. We've proved what we wanted to. There are no flaws in our argument. Nobody will be able to refute it. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.